Okay, in this lesson 3-4, the topic is still slope, but this time we're talking about slope from a different perspective. We're kind of looking at how to find the slope from the graph and what that looks like. And so from the graph, you can get the slope by counting the rise over the run between 2 points that are on the line. So a quick example of that, let's say I have a graph sketched here, and let's say 1 point on there is going to be back 1 and down 1. Alright, so left 1, down 1, there's your first point. And let's say my second point on this line is going to be over 1, 2, 3, and up 1. And then there's my second point, and I've got a line through those points. Alright, so there's my line. Let's say I wanted to find the slope of that line. Alright, I can do that by counting the rise over the run. And like I say, hopefully that's a technique that you're familiar with from algebra. And so if I wanted to find the slope of this line, then the slope would equal to the rise over the run. So let's count the rise and put that on top. And so rise, remember, you're always going to go from left to right, the left point to the right point. So I need to start here. Now, here's the first thing I want to do. Should I rise up or down to get to the other point? Okay, this will help you determine whether that top number should be positive or negative, and the entire slope actually positive or negative. If I have to rise up, then that's a positive slope, and I do have to go up by 1, 2. So my rise here on this is going to be up by 2. So 2 is going to be the top number. Alright, now we need to figure out the run. How far do we have to run? Alright, my run's going to be 1, 2, 3, and 4. And so rise over run would be 2 over 4. And reducing down, that would give me a slope of 1/2. So 1/2 is the correct slope for this particular line that I got here. Okay. So again, that's kind of an example of how you would find the slope using rise over run. Now, if you know what these 2 points are, you can write out the coordinates, and then you can also find the slope the same way as we did in the last lesson from the 2 points from that formula. That would also give you the slope. But if you have the graph, you can also count rise over run and get the slope that way as well. Okay. Now, before we move on, let's just kind of talk about some visual cues that you can use to tell some things about the slope before you even calculate anything. Like, for example, if you see a line like this that's sloping upward from left to right, you automatically know that that line has a positive slope, right? And so if you go to calculate the slope of this line and you get negative something, you know you did something wrong. Likewise, if it's sloping downward from left to right, that's a negative slope. Okay? And if you've got a horizontal line, okay, then the slope is 0. And here's kind of why. When you look at this, if you go from here to here to count the rise over the run, well, what would the rise be? Rise would be 0. And the run in this case would be 2. 0 divided by 2 makes 0. So a horizontal line has a slope of 0. And so what about a vertical line? Vertical line, if I'm looking at this one, then again, vertical lines have an undefined slope. And here's why. If you count the rise over the run, the rise would be 2. But the run would be 0, actually. And so division by 0 is something that you can't do, so it's undefined. Alright? And so, just real quickly, sloping up from left to right, positive slope. Down from left to right, negative slope. Horizontal, slope of 0. Vertical, undefined. Alright? So you can very quickly look at a line and tell something about the slope, just based on the way it looks. Okay? Now, here's something else that's important. Parallel lines are going in the same direction, right? So if lines are parallel and they're going the same direction, they would have the same rise over run, which means parallel lines have the same slope. Same slope. Alright, so this is extremely important to know. Parallel lines have the same slope. If you've got 2 lines that are parallel, their slopes have got to be the same. So if I have one line and the slope is 3, then any line parallel to it would also have a slope of 3. Parallel lines have the same slope. They're going the same direction. They'll have the same rise over run and therefore the same slope. Now, perpendicular lines have slopes that are called opposite reciprocals. Opposite reciprocals. So opposite means different signs. Reciprocal means flip the fraction. So change the sign, flip the fraction. That's how you can get the opposite reciprocal. So the next part of our lesson is spending time practicing finding the opposite reciprocal, because if the slopes are opposite reciprocals, then we know that those lines have to be perpendicular to one another. So like for example, if I know that the slope of one line is 3 over 4. If I want to know the slope of a line that's perpendicular to it, then I need to do the opposite reciprocal. Well, opposite means they got to have different signs. So if the first one's positive, the next one's got to be negative. Change the sign, flip the fraction. 3/4 flips to 4 over 3. So the slope of a line perpendicular to this one with 3/4, it would have to have a slope of negative 4 over 3 to be perpendicular. All right? So opposite reciprocal is what we're going through and trying to find here. All right, so what about this next one? Let's say I wanted to find the opposite reciprocal here. Opposite, change the sign. Reciprocal, flip the fraction. Change the sign from negative to positive. Flip the fraction to 5 over 2. All right, so again, make sure that we don't lose sight of what this means. Okay, if the slope is the opposite reciprocal, then these two lines would be perpendicular. All right, so let's continue some more so we can get good at it. Opposite reciprocal of negative 8 over 5 would be positive 5 over 8. Opposite reciprocal of 5 over 4 would be negative 4 over 5. Remember, I'm changing the sign, flipping the fraction. The opposite reciprocal of 3. Now, when we come to this one, okay, this is the first time we got to think about it a little bit. Opposite is negative, we know that much. But what's the reciprocal of 3? Well, reciprocal means flip the fraction. Well, 3 is not a fraction. However, I can make it a fraction. You can just put it over 1, right? 3 over 1. So if it's not a fraction, make it a fraction, and then flip it to 1 over 3. So the opposite reciprocal of 3 is negative 1 over 3. Okay, so what about this one? 1 over 8. I want the opposite reciprocal. Positive, change it to negative, and then flip it to 8 over 1. But 8 divided by 1 is just 8, so the over 1 part is unnecessary. And so the opposite reciprocal of 1/8 is negative 8. All right, what about the opposite reciprocal of 4? Well, it would be negative 1 over 4. Because remember, this is 4 over 1, flips to 1 over 4. What about the opposite reciprocal of negative 1 over 5? Well, negative 1 over 5 flips to positive 5 over 1, which is just 5. Okay, so like I say, if it's not a fraction, you can make it a fraction and then flip it. Okay, now, here's something to keep in mind. The product of opposite reciprocals is always 1. If I were to take any of these two and multiply them together, it's always going to be negative 1 every time. All right, so if you want to know if two slopes are opposite reciprocals, you can just put them in the calculator and multiply them out and see if you get negative 1. So like here, the 4's would cancel. Positive times a negative is a negative, so we know it's got to be negative. And then so like 4 times negative 1/4 is negative 1. Negative 8 over 5 times 5 over 8 is negative 1, because the 5 would cancel, the 8 would cancel, everything is 1, and it's negative because it's a positive times a negative. So that's a fact that we just need to be familiar with. The product of opposite reciprocals, if you take those numbers and multiply them together, you're always going to get negative 1 every time. All right, so again, make sure we recognize what this means. It all goes back to this. Parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. So if I have two lines and their slopes is 1/4 and 1/4, what's the conclusion? Well, they must be parallel. Why? Because the slopes are the same. If I have two lines and the slope of one is negative 2 over 5 and the slope of the other one is 5 over 2, what's the conclusion? oh, these two lines must be perpendicular, because perpendicular lines have slopes that are opposite reciprocals. So these are the two facts we need to make sure that we know in order to answer the type of questions they're going to ask me for this particular lesson. Now let's try some of them. Alright, so what we've got here is a diagram that we're going to be looking at, and it's a graph really, with several lines that are graphed. Several points are labeled on here, and the coordinates are filled in for those points. And so based on this graph, we need to answer these questions. I want to find the slope of line AB. I want to find the slope of line AB. Alright, let's find AB. Line AB is here. So to find the slope, I can do it two ways. I can use the formula with these 2 points. Or for me, I think it's easier to just count rise over run. So let's count it. Alright, so rise over run would be 1, 2, 3, 4, 5, 6. That's my rise. So M is equal to 6 over, what's the run? 1, 2. The run is 2, so I'm going to put 2 at the bottom there. And then that's going to divide out and make the slope 3. So the slope of that line is 3. What about the slope of CD? Let's try that one. So M equals, right? So I want to find the slope now of line CD. Okay, so line CD is here. Just by looking at it, I should know that the slope is negative. And so as a matter of fact, I'm going to go ahead and put that in the front of the fraction because I know it's going to be negative something. Negative. Alright. Let's see here. So it's down by 1, 2, 3, 4, 5. So it's negative 5. Over, the run is 1, 2. And so it's negative 5 over 2. And then that's your slope of this thing. Negative 5 over 2. Alright. So there's my slope. Negative 5 over 2. Alright, the next one. CA. Alright, so here is line CA. I know it's got to be positive, so slope's going to be equal to, the rise is 1, the run is 1, 2, so that's 1 over 2, and then that cannot reduce, so there's your answer. That's the slope of line CA. It is going to be 1/2. Let's try the next one. Measure the slope of line AE is what we're looking for now. You can find the slope of line AE. So let's look at AE. AE is going down from left to right. I know that's a negative slope. I'm going to go ahead and write that in. Alright. Now, let's check the rise over run for AE. The rise is down by 1, 2. So I'm going to put 2 at the top. And remember, I already wrote the negative out there. So make sure you're aware of that. So it's down by 2 and it's over by 1, 2, 3, 4, 5, and 6. So the run is 6. That means the bottom number is 6. And all I have left to do now is reduce the fraction that I have. And so 2 over 6 reduces down to negative 1/3 is the correct slope here. Alright, so that's what we've got. Okay, next line is BD. Okay, so let's look for line BD. Alright, so line BD is here, and that is a horizontal line. Now, remember what we said on the other page. If it's a horizontal line, what kind of slope does it have? 0. So I can go ahead and write in 0 as my slope and be done with it. Call it a day. Alright? Let me see here. Slope is 0. And so we're good there. Alright, now what about line AD? Let's check that one. So line AD is a vertical line. And remember what we said about vertical lines? The slope is undefined. So I'm going to go ahead and write in undefined here for my slope. Okay, and so that's the easy way to find slope from rise over run. Just remember, horizontal line is a special case and vertical lines are a special case. Horizontal line, slope is 0. Vertical line, slope is undefined every time. Alright, now, here is where we're actually going to be tying in this concept. Remember what we said earlier? Parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. So these following 4 questions, alright, test to see if you really know what that concept means or not. Look at this question. Alright, so the directions are find the slope of a line, okay, parallel to AB. So first the question is find the slope of AB, find the slope of CA. So find the slope of a certain line. Now the directions are find the slope of a line parallel to AB. Alright, Now, let's stop right here for a minute. Okay? If I want to find the slope of a line parallel to AB, what do we know about parallel lines? Okay? Parallel lines, we know, have the same slope. So what that means is, and remember, I already figured out the slope of AB up here in the previous problem. All right? So the slope of AB, if I've done it correctly, that's the other thing, is 3. Okay? And so if I did this wrong, then that's automatically going to make this next question wrong. All right? So the slope of AB we found to be 3. Okay? So the question is, what's the slope of a line parallel to AB, which is 3? Well, again, parallel lines have the same slope. So if the slope of AB is 3, then the slope of any line parallel to it will also be 3. Why? Because parallel lines have the same slope. If AB has a slope of 3, then a line parallel to it will also have the slope of 3. And then so that's the answer to that question. Parallel lines have the same slope. So if one is 3, the other one has to be also 3. All right? Now, what about the next question? Okay, next question says that I want to find the slope of a line that is perpendicular. Don't forget your symbols. Perpendicular to AB. Okay, so once again, the slope of AB is 3. I want to find the slope of a line perpendicular to AB. Well, remember all this while we're doing this. Okay, because perpendicular lines have slopes that are opposite reciprocals. Okay, so if AB has a slope of 3, then any line perpendicular to it, okay, would have a slope that's the opposite reciprocal of 3. So I need to find the opposite reciprocal of 3. Well, opposite would go from positive to negative, so it's got to be negative something. Now, what's the reciprocal of 3? All right, what's the reciprocal of 3? Remember, that's 3 over 1, so it flips to 1 over 3. And then there we go. All right, so the slope of a line perpendicular to AB would be negative 1/3. Why? Because 3 and negative 1/3 are opposite reciprocals. So again, with these types of questions, if it asks what's parallel, it's going to be the same. And if they ask what's the slope of a line perpendicular, you must do the opposite reciprocal. Change the sign, flip the fraction. So that's tying the whole point of the lesson together with these types of questions. Okay, so now I want to find the slope of a line parallel to CD. Well, I already found the slope of CD. It's negative 5 over 2. So what would be the slope of a line parallel to CD? Well, remember, parallel lines have the same slope. So if the slope of CD is negative 5 over 2, then the slope of any line parallel to CD would also be negative 5 over 2. And then that would be your answer. All right. In the next one, I want to find the slope of a line perpendicular to CD. Well, if line CD has a slope of negative 5 over 2, I need to find the slope of a line perpendicular to it. So what do I need to do with this number? All right, I need to take the opposite reciprocal. Change the sign to positive. Reciprocal, flip the fraction. 5 over 2 flips to 2 over 5. And then that is your correct answer. And we are done.